my topic is on this speed methodology that we have tried as a pilot in this project. It's a kind of methodological way that we tried in the project, and the agenda for today for my talk is briefly about our company. I think Patrick spoke a bit about it just now. Then I will talk about the methodology and how it relates to the work package 2 in this CAMS project. And then I will take some conclusions and lessons learned from this project, and I will sum up with some opportunities and remaining challenges that we still are facing in SEAS. So a Nordic Energy Audit about us. We are a small company, a startup, since I call it 2019, but it's actually based on this the Fram database that Patrick spoke about. Founded by Professor Patrick and his colleague Magnus from Linköping University. And we like to see ourselves as frontrunners within energy management and energy policies. And we have developed this software for large-scale energy data handling, as we call it, and we call it NEED. Our team in this project has been myself and Patrick, and then, as he also mentioned, we have Lana on the line here as well, which is based in Russia. Myself is in Stockholm for the moment. So a bit about the background and why we are here and why I'm talking today is, of course, this urgent need to cope with the climate changes and decarbonize society. But as we all know, and as we have previous speakers told us as well, is that energy efficiency is the first fuel in driving the green changes. We also see a great need for energy audits, energy declaration, energy passports, as they are very good means in order to identify and increase the energy efficiency potentials out there. And on that topic, we see that there is a great untapped potential from uncollected and non-harmonized data, as we also have been mentioning here earlier. So what we wanted to do here is, to harvest this untapped potential and bring, show the opportunities with what one can do with this kind of data. And the data I'm speaking about is mostly from energy audits and declarations and such, mostly about energy end use. So some of the aims that we had when we started this work package, it was that we wanted to increase the pace and reduce costs for energy audits, but also similar means like declarations and such. We wanted to reach a higher quality and reduce costs for audits as well. So that's a bit of a challenge as well. Furthermore, we wanted to establish baselines and enable benchmarking with this high quality data. And this would hopefully result in generating new key knowledge that can be used, for example, for the design of policy and policy programs and energy efficiency programs as well. A bit about the methodology that we applied. Since we have spoken earlier as well on this discrepancies that we see in data handling and what is an energy declaration in Sweden is not for sure the same thing in, for example, Latvia. So we tried to apply this speed methodology in order to harmonize the way of working. The first key component is that we need to have some kind of stakeholder responsibility and involvement of the value chain, all the way from where energy is being used, all the way to policymakers and decision takers. So we need to have a value chain involvement in order to, as Patrick said, not have these kind of tool and initiatives ending up in the tool graveyard. Secondly, clustering target groups is very important since we cannot compare or collect data for different sectors in the same way. We need to make a differentiation of, for example, residential buildings and industry companies, for example. In this case, as we all know, we have looked into residential buildings primarily. A third component is a golden standard for energy data. Patrick spoke a bit about it, but it's basically that we make sure that we have this taxonomy in place and we call everything the same. We define processes in the same way. So space heating is actually a clear specification for everyone. Whoops, there we go. And fourth, a central database is we think it's very important that we collect everything in the same database, since if information is fragmented across many places, analysis and macro analysis in particular will be difficult to do. And in this case, we have two databases, one of energy end use, and the other one is about energy efficiency measures. So there is a differentiation there. And then, of course, the fifth point here is the component is a digital platform that is easily to access and pretty easy to work with. So all stakeholders can use it and it's accessible for everyone. In this project, we did some pilot audits. There was primarily in residential buildings, but we also had some cultural houses, kindergartens, some offices as well. And here are some pictures of them. It was from 5 countries, all in all. In total, 33 audits were registered in this platform across 4 NACE divisions in 5 countries, 12 regions, and 19 municipalities. So there was a quite spread on both geographical and a bit on NACE divisions as well. But in total, we mapped 365 gigawatt hours and 65,000 tons of carbon dioxide. All were collected and visualized in this platform. I wanted to show you a bit about a brief example of what energy quality or energy data quality may look like. So in this case, we found out that there was a big differences in the quality of data that was reported. In this case, we can see this is actually one of the energy audits that we see that all we got was input district heating to a building, which is pretty difficult to do anything with, actually. The next audits that I want to show was a bit more precise. We have some kind of differentiation on how the energy use were spread in this building. So we had district heating, but we can see where it's being used, and the same goes for the electricity. One of the highest qualities of audits was this one, which shows a pretty good spread on how much energy that's being supplied and where it's being used. And this is quite powerful if we can get it across, and if we can get this into a systematic approach. Then, of course, we can always discuss calculation method, etc. But if we have this kind of approach, there's a much more stringent way of working. Another example that I also want to show is the establishment of baselines and benchmarking that we did, and this is from the housing sector, where we can see overall energy performance, megawatts hours per square meter, which is basically what energy declarations shows. And we can see here in the graph that the blue dots is the data, the existing database that we had, which lines as a baseline. And then we can see the green dots that are actually audits from this project. So we can see that all of these dots are green and nothing stands out. It looks kind of good. We have a pretty good overall energy performance of all these buildings that are being accounted for. But if we apply the method that I showed you just before, where we have defined, for example, how much energy that's being used on lighting, then we can see that a couple of audits stands out and are maybe not as good performing as we maybe thought in the previous graph here above. So this is one pretty concrete and clear example of how this type of methodology can be used. And you can also aggregate it, of course, into a sector or geographic location, etc. I will show you in a bit. But what about efficiency measures? We know that efficiency measures is key. We have said it before today as well. But we saw that we wanted to report efficiency measures as well, because it's one of the parts that are being included in an audit. So we saw as before, we have a high difference in quality. Some were excellent and some were less excellent, so to speak. We identified a saving potential of 2.80 gigawatt hours and 500 tons carbon dioxide. Interesting to see is that actually all of the measures that were reported were mitigation measures, not adaptation measures, which may be logical since it was an energy audit that was being conducted. But it's interesting to highlight as well, I believe. And as before, we compile the results in the database, in the platform. I wanted to show you two graphs here as well. One showing energy end use, how much percentage of where energy was being used, and how it related to the amount of proposed measures from the audits. So we can see space heating has 67%, 68, more correct. And then it corresponded to 64% of the proposed measures, which is kind of reasonable. But looking into, for example, this category of hot tap water, which was 20% of the energy end use, only 3% of the proposed measures were in that category, which is noticeable, I believe. Because if we look at ventilation, that only stood for 2.6% of the energy end use, the corresponding proposed measure was 16%. So there are some interesting results here that can be highlighted, I believe. More hands-on, this is an example of a reported measure, which follows this standard that we are advocating, how one should report energy efficiency measures. I will not go into detail on any of this, but we see that it's some key information is vital in order to make others benefit of previously reported measures. So if I am to say I want to do some a measure in the category of space heating, I can quickly get an overview of how much savings is this, what does it cost, what was done in brief, and how much can we save approximately, payback time and such. So this is one example of how we think a reported measure should look like, because this is information that already exists basically when doing an energy audit, if it's a good one. One of the most interesting results I believe this work package had identified is the cost intensity of measures. So we see here on the x-axis we have energy savings, which is basically how much energy can we save, and on the y-axis we have cost intensity. What do we get? How is the bang for buck basically? The lower, the better. We see that in the bottom here we saw that lighting and tap water measures were very cost efficient. But as we can see here, there's not much saving potential since there were not so many measures proposed in these categories. And in the next one, we have ventilation, which was a pretty more expensive, but still okay. And we saw larger potential there as well. Then comes energy supply, followed by this category of space heating that we saw was the most popular measure to propose. And at the same time, it's the most expensive ones to do. So this is where I think it's very interesting that we see that a lot of focus was spent on measures that were 10 times as cost intensive as the more cheaper ones were. So this is one typical results that we can, if we can get this type of information in a larger scale and from large regions or branches, etc., I think there is much to be won here. I don't know how I am on time here, but I think it's okay. I have some.
You still have time, yeah.
Okay, great. So I want to connect to the things that I introduced earlier, the purpose and aim here. So if we look our own conclusions here, we wanted to increase the pace of energy audits. We are not 100% positive that this kind of methodology will do that, but in a way it might do, since we can contribute to a standard format on how to produce and perform an energy audit. If we get specifically which data points that are to be reported, we can possibly speed up. I know exists this type of standards today, but I think they are still open for auditors to decide for themselves exactly what to report. On the same topic, reduce energy audit costs. We're not sure about this, since we are demanding a bit more from what an energy audit and maybe an energy declaration should contain. But on the same topic, if we can provide this kind of standard format, maybe we can at least keep it at the same level. Higher quality we can for sure achieve. Since we have this centralized collection of data, we can compare it and we can see where things stand out, what is a reasonable level for energy use, etc. So that we can achieve. Establishment of baselines and enable benchmarking. We also think that we can do this by this kind of methodology. And we think it's pretty hands-on as well, since we can easily identify where things stand out. And as I showed you in, for example, this McKinsey curve, or a conservation supply curve of cost intensity, we think that we can generate new key knowledge for the design of policy and energy efficiency programs, and we can also evaluate them. Some of the achievements not related to the targets that aims that we set up in the beginning. we have applied a concrete approach and methodology on how to work with digital tools, energy efficiency, and decarbonization. We were not sure in the beginning if this would be possible, and it was, I think, all project partners can agree that there have been some confusion on what an actually energy audit is, or what an energy declaration is, and how to handle these type of challenges. But in our point of view, we think that we have applied a concrete approach on this. And we have as well collected, harmonized, and visualized energy environmental data from different countries and different sectors, which is, I think, it's encouraging to see at least. One of the most, as Patrick said before, one of the most cost-intensive processes is to do quality control of energy data. And I think by doing this kind of approach, we have proven that we can do a quality control of energy data or we have done this manually in this project, but of course it can be controlled by algorithm and such. And we also believe that we have showed a proof of concept how to generate new key knowledge for policy and decision making as well. I have some inspirational pictures that I just wanted to show for you who hasn't seen these before. But some of the possible analysis that we can do with this kind of approach is, for example, as I showed before, cost effectiveness. Define which processes that are most beneficial to use in the left graph there. So maybe put less focus on space cooling, as we see here, and put more into, let's say, hot tap water, as we said. And on the right hand side here, we can see that this can be used as a kind of decision step, where you can start. You should not do measures that are on the far right, which are expensive. You should start on the bottom left, where you have the most cheapest and least cost intensive measures to be done in, for example, a building. So you work yourself from the lower left to the upper right. And if we spread this across different sectors, in this project we had 4 sectors involved, but we can also identify saving potentials in different branches or sectors, so to speak. Where should we put our focus? And as we said, renovation wave is very important. Also, this kind of regional follow-up would be possible to get automatically if we can put collection into a system over time, where we can follow investments, different type of KPIs, whatever one would like, how much energy that's being saved, how big investments that are being made in different regions, etc. My final slide here, I think, and this is one of the, I think we have not come to a conclusion on these types of challenges still. But important to highlight here is that if one should put this kind of approach and methodology and system into place, who will be responsible for maintenance of the system and keep it running and make sure that data is being inserted into it? Who are paying for this system? Is it the end user, or is it for example, an authority? Also, questions about who should enter this data and why should they? That is one of the key questions, I think. In this case, we had most of the auditors entered data. I think some of, for example, Alina with colleagues also inserted data. So it can be done in many ways, but I think it's important to know who would do this and why. And then, of course, we have these legal compliances that are a challenge, of course, integrity and such. I think that's it for me. If you want to look, we have a final report in the CAMS website that is accessible, where we have spoken a bit about policy recommendations, and also you can read more about how we have applied, for example, the quality control in this. And then we also have an open access to the software, where we can look for yourself the results on the data that has been inputted. And any questions or such, you can write me an email and I will answer, of course.